Ka1 values in decreasing order for following acids. You can see the structure for compounds. There is a carboxylic group and an amino group in the first compound. Carboxylic acid is an acid, whereas amino actually acts as a base. In the next compound X, we have two carboxylic acids, and we can identify this that it is both the carboxylic groups, similar groups are on same side. So, therefore, this is the cis isomer. Dicarboxylic acid, two carboxylic acids are there. Acidic strength of this will be more than when you have an amino group and a carboxylic acid group. In the next compound Y, once again we have a carboxylic acid and a amino group. This is now the cis isomer. If we compare with the first compound W, then we can spot that W is the trans isomer. We can also call the cis isomer here as Z and the trans isomer here as E. When we see the last compound here, the carboxylic groups, there are two and they are on the opposite sides. So, it is actually a geometrical isomer of X and this would be the trans isomer. So, W and Y are stereoisomers or geometrical isomers of each other. X and Z are geometrical isomers of each other. Now, out of these, X and Z are more acidic, as we can see that there are two carboxylic acid groups. In X and Z, the isomer, cis isomer, which has both carboxylic acids on the same side, this will be more acidic. The reason being hydrogen bonding. When this carboxylic group loses this proton and a minus charge is formed here, as this another COOH group is also on the same side and it contains a hydrogen attached to electronegative atom, there is a force of attraction between this electronegative atom and hydrogen attached to electronegative atom. This itself is called as a hydrogen bond. Hydrogen bond stabilizes this anion and hence makes it more stable. Therefore, the H plus gets lost easily because a stable compound is formed here. If we apply the same logic to this trans isomer, that is this Z compound, then if this carboxylic acid loses that proton forming a negative charge here, then it is very difficult for this hydrogen to bond here with this O minus. Hydrogen bond is almost impossible here because the groups are on opposite sides. Therefore, that stabilization is not occurring there. Hence, we can say that X is more acidic than Z because X is the cis isomer where COH groups are on same side and hydrogen bonding is possible on the anion. Z is the trans isomer. Similarly, when you are comparing Y and W, once again we can say that Y is more acidic because if this H plus is lost, then we have a force of attraction between this O with the minus charge and this hydrogen which is nearby because it is once again the cis isomer, as compared to W where the hydrogens of NH2 group are quite far away. Hence, the order is X greater than Z greater than Y greater than W.